Hello, everybody. Dr. Charlton here today. I'm going to show you how to get a data set from this data is from a student survey and actually analyze it and do statistics on it. So this is just an introduction to kind of get your feet wet. And these are things that we're going to spend the rest of the semester really diving in deep and learning very well. So first of all, there are three packages that I'm going to use for this exercise. I'm going to go ahead and load all three. You notice all this stuff in green. This is comments. This doesn't do anything. It doesn't run. It's just there for my information. Now, if any of these packages I don't have, I could run the install.packages function and put the name of the package in there. And I could get that package into my um, R installation so that I can then run it with the library function. So that's a one-time thing, the install.packages, but library, I'm going to run that function every time I use it. Now, I do have a link to the actual data set. So if I go to it, I get this. I get this page right here. This is the Ideal Student Life Survey. It's from Kaggle, which is a data competition type site. They have a lot of free data sets. Sometimes I like to use them. It does talk about what each variable means, but it's kind of hard to follow. So I'm going to go ahead and look at the variables right here once I import the data set. So it actually gives two data sets. I'm going to call one experience raw and one is experience. So I'm going to load both of these data sets in. And then the raw one, let's start with raw. Let's see what the raw data is. So they actually manipulate this data. So I've got experience raw. Now, if I click on this grid right here, it runs the view function. Now you can see actually view is output right here. And so you could type that in and run it, or you could just click on it. So I have all the questions they asked in this data set. Okay, so for subject number one, it looks like they didn't volunteer for anything, and they didn't participate in societies and interest groups. They did participate in clubs. So you notice all these are Q2s, and so actually you could combine all this and have count data, right? So we could say this is a 0, 1, 0, 0, 0. And so then my total count is 1 for this first row. So they've only participated in one thing. So their Q2 overall answer is 1. And then if I go over here, I can see for Q3, they have some no's, some yeses. If I add up all the yeses, then I get a number for Q3. So you can see I could come up with numerical data. And that's in fact what they did. So I'm going to show you. So I'm gonna load up their cleaned data set, and it's gonna actually combine all those variables so that you have counts for each thing. And while I'm doing it, I'm renaming a bunch of these variables. So this looks like a big sloppy mess of code, but it's very simple. I'm just running the rename function, and I'm tweaking all these variables to be variable names that I can actually use because the other ones were kind of too long and unwieldy. So now Q2 that we looked at before, Q2, how many events have you participated in, is now just participate, just to simplify it as we run data analysis. So I run that. All right, so I've run this code. So you can see, again, just to review, I have two functions in here. So I'm going to read in a CSV file that's at this web address where anybody can download it. And then I'm going to rename, as the CSV comes in, I'm going to rename all these variables. So this is going to be the new name. This is the old name. I'm getting rid of spaces and capitals, which I don't like to work with, and shortening a lot of them, like program is a lot nicer than primary program, spelled with a British spelling, I assume that is. And also, R really doesn't like these spaces. So I'm trying to go without spaces. So I've simply renamed them to cleaner variable names is all I've done. And it looks complicated, but it's pretty straightforward. So again, just two functions, read CSV and rename. And then I've saved all that. So first I've read in the CSV, then I've renamed all the variable names, and I've saved it as experience. So now there's a data set called experience that I can open and look at. And you notice before we had several Q1s and Q2s, Q3s, etc. Well, now we just have counts. So Q2, I believe, was all the participation ones. Now it's a variable called participate, and we just have counts. See? So for every person, so every row is one person, okay? So I have almost 3,000 people in this data set, and it has their department, it has, and then it has all the rankings on all these scores. So what I'm interested in is seeing, I have to pick a variable of interest. Maybe I pick stress, okay? So I want to see what makes students more or less stressed out. So maybe I'm interested, maybe I'm a stress researcher for whatever reason. I want to understand stress. So I'm going to, here, I can also run this code and show you all the names of the variables in the set. So I'm going to look at the relationship between stress and I'm going to pick a variable. I'm going to say participation. So let me look back at experience raw and I'll show you what was all on participation. So yeah, it's Q2. So it's a count and it's like add up the number of how many societies, interest groups they participated, plus the number of clubs, plus the number in halls, JCRCs, and or residential colleges, CSSCs, I don't even know what that is, participate in university organized events. So they're just participating in all these things or other things. And you just get counts for all of these and then add it up. That's their number. So you can see, so for participation, it can be anywhere from 5 to 0. See, I keep sorting it. So 0 is the lowest, 5 is the highest. And then for stress, let's see what the stress variable was in the original raw data set. So I'm going to look for stress here. Okay, stress. So it just counts. Are you stressed about adjustment issues? Are you stressed about academic issues? Are you stressed about financial issues? Are you stressed about family issues? Are you stressed about friendships? And so if they say yes, like this first person says yes one time, that's it. So they're going to have a count of 1. That's going to be their value because they're saying no to all these others. They only said yes to academic issues. So they are stressed at a level of only 1. They're only stressed about academic issues. Okay, so I'm going to plot. What I want to look at is there some kind of relationship between stress and participation? In other words, are you more stressed or less stressed if you participate more? So I'm going to pause for a second so that you can just think about that. We want to find out what can make somebody more stressed. Now, if they're participating, again, by participation, we're talking about all these things over here on Q2. So if they're participating in groups and clubs and all those kinds of things, will they be more or less stressed? On the one hand, you might argue that they would be more stressed because they're really busy and they got a lot going on. But on the other hand, you might argue that, well, it's only the kids that are already, in a really good place and a really good situation that will even participate in those things. So they actually might be less stressed. You could argue either way. Let's see what the data says. That's what we're here to look at. So first of all, I'm gonna do a quick plot here. This plot, experience. Okay, so I've got the data set called experience, which is what we were just looking at. And my y-axis is going to be stress. The y-axis on the left is always going to be the outcome variable, and the x-axis underneath is participate. So as we participate, does that influence stress? So I'm going to start trying to plot this out, and I'm going to layer it in and make it cleaner. So first of all, all you see is a big grid of black dots. And the reason is because there's a lot of repeats, okay? So you can be 0 and 0. You can be 0 on stress and 0 on participate. But we don't know how many people fall in that category. You can be, let's see, this is 2. You can be 2 on stress and 2 on participate. That's this right here. And we don't really know how many people fall in that. We could actually add an alpha to get an idea, because then it will be darker depending on how many people are on that exact same dot. See how some just faded away, and we can actually increase our alpha there. So we can increase our alpha and say like 0.05, and then even more faded away, but still we got a lot. So let's see, let's do an alpha of 0.01. Okay, so some are starting to fade away. So you're starting to see them, the really black ones are stacked where there's a lot of dots in that category. Another thing that we can do is, instead of a geome point, we can actually do a geome jitter, so that what that does is it offsets all the dots so that they're not stacked on top of each other. They're kind of piled close to each other. But first of all, before we do that, I want to clean up the grid a little bit, because what I've noticed is everything falls on an integer value, but we have all these grid lines and tick marks that don't line up with our integer values. So I can actually, let's see, add some code right here. I'm going to copy this up there. So first of all, on the y-axis, I want to have a sort of a tick mark from everywhere from 0 to 9 on all the integer values. So sorry, I don't know what happened there. Had a little hiccup there. All right, so I want it to be, so first of all, let me just run it with just that, and we'll see how that changes the y-axis. So the y-axis is on the left, that's the stress axis. Now if I run this code, let's see how it cleans it up. See how it cleaned that up? So now I have, you see how all the dots line up with the actual numbers that they related to? I'm gonna do the same thing for the x-axis. So watch the x-axis, so actually the x-axis is already pretty clean, but we're gonna run it anyway. And it looks like it didn't change it because it was already pretty clean. And now I'm gonna get rid of those extra lines. We don't need the lines at the halfway mark in between these numbers, because that's not possible values that we can see in our data set. All right, so now you could have stress of 5 and you could have participate of 3, and we can easily see where that is and where that lines up. So that's a lot cleaner. The next thing I'm going to do is I'm going to do a jitter plot. And so when I do the jitter plot, what it does, it will offset all these guys so that they're not stacked right on top of each other. They're next to each other. I'll show you what I mean. Okay, so if you're at 2 and 2, that's this whole cloud right here, okay? So it's jittered it. So instead of everything being stacked on 2, it's like everything is like bounced away, so that you can kind of see how it spreads out a little bit more. And I probably don't need quite so much alpha for that, so I'm going to bring my alpha down. Whoops, I ended up on the wrong place. Okay, let me try again. So I'm going to bring my alpha down to point. Wait, what was it? It was 0. Okay, so that darkened it a little bit. You can see I have a lot of 1s for participate, a lot of 1s. And those 1s, they're pretty low on stress. Now, it looks like, I feel like the more you participate in, you might be kind of more up here on the higher stress, but it's kind of hard to tell right now. So we're going to have to keep moving forward to figure that out. We're actually going to fit a slope to it, fit a line to it. It uses basically something like regression. It uses sort of a statistic. So that's going to be, if I come back here, I'm going to do a geome Or what is that geom called? I don't have that saved. Geom, I think it's slope. I don't know. I'm just guessing here because I don't have it in front of me. If it doesn't work, I'll pause it and find it. Geom slope doesn't have geom slope. All right, so this is, I'll just troubleshoot it with you. So slope in ggplot2. It's not a AB, it's not any of these. Okay, so I'm just gonna get the ggplot2 cheat sheet, and I'm gonna show you how to find it in the ggplot2 cheat sheet because I feel like that's a good exercise. So you can go to RStudio and pull it in from there. All right, so I want like a slope like this. I want a geom smooth. That's what I want. And I'm gonna do model equals LM. Okay. Let's see. So I'm back here. So it's not slope, it's smooth. Model. I got my wording wrong there, my bad. Let's see if that worked. Maybe it was method. Method worked. Yeah, method worked. I don't know why it said something. It said model there. Model equals LM. I ran method equals LM. But anyway, you can see here all the different kinds of charts that you want to do. It gives you the code. It gives you the function name to put in a ggplot to run it. So this is super useful. You don't have to like memorize stuff with programming. It's all about just being able to just kind of knowing what you want and how to explain that to Google and being able to find it. So you can see I have a line there that goes higher. So as participation increases, stress increases. So if participation is 0, stress is between 2 and 3. If participation is 1, then it's almost 3. If participation is 2, and this is on average across my whole data set. If participation is 2, then stress is 3. If participation is 5, then stress is a little bit higher than 4. So there is a linear relationship between participation and stress. The more you participate, the more stressed you are. Slightly, it's slightly, but it's actually a pretty strong effect because you see these gray bands around it. If it wasn't a very clear effect, the gray bands would be really wide, but actually they're very narrow, saying that it's a pretty strong or pretty clear effect. Okay, so let's see. So what's next? Well, we can actually do what's called a regression, which is where we use a statistical formula to see if X, in this case participate, has an effect on Y, which is stress. Okay, so I'm gonna sort of delete this. I'm gonna use a function called LM. LM stands for linear model, and this is the regression function. So I don't know if you remember from statistics when you learn this. Hopefully everybody has had a statistics class. Statistics and regression specifically just helps you determine if these two variables are related. So if participate goes up, does stress go up or down? Or maybe it doesn't do anything. We don't know. So if it doesn't do anything, that would be like a horizontal line. So horizontal line would indicate that as participation goes up, stress stays the same. So it has no effect on it. Now, if it's a slopey line that slopes up to the upper right corner like this one does, that's a positive effect. So the higher participate goes, the higher stress goes. There's also negative effects. So participate potentially could negatively impact stress. In this case, it doesn't, but that would be it would slope downward. It would slope, in the more, from the upper left down to the lower right. That would be a negative slope. So that's pretty much how it always works. And I'm just introducing you to it today, but we're going to go into it in more detail. But first of all, I'm going to go ahead and run this regression model. So you can see I've loaded up a model where I have the name of my data set right here, which is experience. and I have my two variables of interest. So I want to see, I have my y variable, my stress variable, and my predictor variable, which is x, and which is participate. So what's the effect of participate on stress? And then I'm going to run that, see what happens. Nothing happens. So I have to do a summary. I have to run the summary function so that I can see what is inside this model. Because you can see there's a model saved over here, but there's no output. So I'm going to run the summary function and I'm going to see what happens. All right. So again, I'm going to spend quite a bit of time with you helping you interpret these instructions. But for now, I'm just going to take you to some key points, okay? So let's see. So this is all I care about right here. Participate has a 0.38 effect on stress. So for every 1 point that participate increases, for every single activity that you increase, you're going to be stressed out in 1/3 of an additional area. Okay. So, because remember, these were both counts. So participate was number of activities you participate in. Stress was number of areas of your life that you're stressed in. Okay. So if I add one more activity, I'm going to be, my stress thing is going to go up by 0.38, which means I would have to add about 3 activities for me to be stressed in a whole new category, because that would be about 1, right? 0.38 times 3 is close to 1. Now I know it's significant because the p-value over here, this is a p-value. Sorry, it doesn't really look like a p-value. This is the p-value. The p-value is less than 2 times 10 to the 16th power. Sorry, 2 times 10 to the negative 16th power. Okay, so that's a really small number. This is scientific notation. And so if you see this and it's negative, if it's positive, it's a really big number. But if it's negative, this is an incredibly small number. And you see these stars here, it's telling you that it is significant. And it's very, very small. All right. So, so 3 stars in this case means that it's basically less than 0.001, the p-value. You want a p-value to be less than 0.05 to be significant. So 0.05 would be 1 star, and that's just barely significant. 0.01 is significant at a lower level, and 0.001, it's significant at the lowest level that we care about, that we're looking at. Okay, so we know from this that that participate does have a negative effect on stress. Okay, and then I could explain all of these numbers here that are output are relevant, believe it or not. I could go through all of these and explain them to you, but we're not going to really do that today because this is just a brief introduction. So all you need to know is there is an estimate for participate. So the effect of participate on stress is to increase it by 0.38 for every 1 point increase in participate. And that is significant. It is a significant difference. So that's about it for your brief, quick introduction to statistics. I've shown you how to visually tell if there's some kind of relationship between X and Y. Again, X is always down here at the bottom. Y is always up here. So I've shown you how to visually look at it to see if there's a difference. It's hard to tell visually a lot of times because there's so much noise in the data. So what we've done is we've run a regression. And I've shown you in the regression how to tell if there is an effect of X on Y. And there in fact is. So that's all I've got for this quick introduction to doing statistics in R. And we're going to dig a lot more into this. So be ready. And let me know if you have any questions. That's all I got for today.